Hey, welcome back, AP Statistics. Let me move myself. That doesn't look right. I may have to do it again. We'll see. This is section 1.1b, okay, the second part of our first section, and this is analyzing categorical data. I'm going to look at two things here, okay? One deals with just a representation of numbers, okay, and making sure that we are analyzing things well, okay? And the second thing deals with some categories and making sure that we're representing both conditional and marginal distribution accurately, okay? We'll talk about those as this lesson goes on, okay? I have just a couple slides. I think I just got like 3 or 4. You'll notice that this first table, okay, is the 2016-2017 World Champion Cleveland Cavaliers. People ask, are you a fan? And I'm not. I just happened to write this problem at this time, and it has some unique characteristics. Okay. One thing that I noticed is that LeBron James, amongst all the players, not only made the most money, okay, $33 million for that season. And that's just playing basketball. That doesn't include shoe endorsements or beverage drinks like Gatorade and whatever. Okay, that's just his basketball salary. And it also represented 23.8% of the entire team's salary. All right, and that's what a relative frequency table is. People forget, what does relative frequency mean? That is a table that's represented either through percents or decimals, okay? Whereas these numbers here are actual counts, in this case of money, okay? And as you work your way down, you can see that they go from high to low, and the weakest player, Kay Felder, still makes 1.3 million, okay? Kind of a dismal amount, similar to what maybe a high school math teacher would make, okay? Nevertheless, if you were to add all these up, okay, I would get around 139 to 140 million for this collective team. Those are the payouts and salary for the Cleveland Cavaliers World Championship team, okay? And again, these are all the respective percents. Now, some people ask, how did we get those? And you can think about it for a second, but it's just simple mathematics. Yes, we're going to take each one of these and divide by this total amount. And once we do that, we'll get some type of decimal. We'll move that decimal point 2 spots to the right, 2 positions to the right, and convert it to a percent. Okay. And if these represent all the players, look how well I do this with my new pen. And again, this is all athletes on this team. These percentages should add up to some particular number, okay? And if you had to guess in your head, what do the players' total percents add up to? You would probably say maybe 100%. Maybe so, okay? So here's what I want you to do. Take your graphing calculator and add all of these up, okay? Start with the 23.8, go all the way to the bottom, add them up in your graphing calculator, okay? In fact, I'm gonna do something different. I'm gonna have you do it a little bit more unique way. I know there's a fast way to do it just on your regular home screen, but I'm gonna show you your first statistic analytical computation on your graphing utility. This is why you spend $80 to $125 on your graphing utility. I'm gonna jump to the next screen real quick just so you can see. On the bottom are a step of sequences that you would use for your graphing calculator in order to find the sum, okay? And here's what I'd like you to do. There's a really cool button here that you're gonna use significantly in this class. It is the stats button. I'm gonna highlight it in red so you can see it, okay? And when you click that stat button, okay, what I'd like you to do is look at the very first line. It says edits, okay? And all you're gonna do is hit enter, okay? So when you hit enter, you get this guy right here. And in your L1, that should be your first item there, it should be blank, okay? If it's not, then do this. Highlight the L1, just move up on your cursor, highlight it, and hit clear enter, okay? Not delete, clear enter. And then what it'll do is it'll empty that respective column, okay? And once those are empty and your L1 is clear, okay, what I'd like you to do is just type in all these numbers, okay? One by one, type them in, okay? And that will appear in this guy right there. Okay. Take a second to do that. Maybe hit pause so that you don't fall behind, okay? And then once you got it, we're gonna move on, okay? If you're not there, hit pause until you got them all in, okay? And then here's what I'm gonna do. I'm gonna go back to that button that was highlighted. It's called Stats, okay? And you're gonna scroll over one to Calc, okay? So hit Stat, scroll over to Calc. Calc is this highlighted guy right there. And the first item that's highlighted under the Calc is something called 1var Stats. And this is a super popular calculation that we'll be working with this school year. Okay, so kind of have that known, have that memorized. And then what you're going to do is, under your list here, you're going to make sure there's an L1 there. My guess is that there's already an L1 there. If there's not, the way you get an L1 there is just by hitting this blue second button and then the number 1. Okay, so the blue second button and then the number 1 will get you that L1. Okay, and then you scroll down to calculate. Okay, and when you hit enter, you're going to get a big list of data. Okay, now the item that we want was the sum, and sum is represented by this symbol here. This is sum. Okay, and what that means is, if you look, we've got 101.7, and that is my respective sum. Okay, so is that the number that I had before? Well, I think before we said this should be 100%. Okay, and if you go back to the previous slide, it says, well, these numbers aren't the same. You have 100 and you have 100 points. What is it? 101.7. Okay, why did we get a difference in values there? Okay, think about it for a second. Okay, maybe hit pause for a second. When you think you know the answer, unpause it, and I'll tell you what it is. You didn't hit pause, or maybe you did. Okay. Reason why is that these numbers here, these numbers on the relative frequency, they're rounded. Okay. The way we find these is taking these guys and dividing by this 139 million. Okay. And in the end, okay, these numbers aren't exact. And what it says is having this 101.7% means that more often than not, we rounded up rather than rounded down. Okay, and so if we rounded up for more of these, it would suggest we would get a percent that is higher than what 100% is. This data is still correct, okay? It was just that in our moment, we had a situation where when we had it around a 1 place value, it gave us something a little bit more extreme, okay? So that'll help us answer some of the questions that we had over here, okay? Again, relative frequency are percents or sometimes decimals of these categories, okay, based off the overall total, okay? All right, we are down to one more slide, okay, and it looks like this. I love talking about food in Costco, all right? The $1.50 Costco is a classic, okay? That's where I took my wife on our first date. We got a $1.50 hot dog and a drink. It's very romantic. We walked around with a cart first, grabbed some samples, you know, I call those hors d'oeuvres. They were free. Sometimes we walked back and got seconds. And then we sat down underneath the picnic table that is inside the Costco that has an umbrella, even though it's indoors, and had a delicious hot dog and drink. So, and anyways, we always refer back to Costco. And then we collected data on 2 special evenings, a Thursday and a Sunday night. And we're looking at, more specifically, their 18-inch pizzas. How many do they sell of each during those 2-day periods? Okay, and you can see that we have a set of data. Okay. Now, before we do anything else, what I like to do is fill in the rows and the columns with the respective totals. Okay, so if I add 12 and 30 up, I think I get 42. If I add these up here, I think I get 63. And this gives me 26. Okay. Also do it this way. Go vertically, sorry, horizontally. 12 and 17 is 29, plus 8 is 37. And let's see, 30 and 46 is 76, plus 18, I think, is 94. Okay, and if you add these up, you get 131 this way, and you will also get going horizontal. Okay, so this number should be representations of both, okay, which they are. All right, so here's what they ask. It says use, in this very first question, over here, use the data in a two-way table to calculate the marginal distribution of types of pizza, and then make a bar graph. Okay. So marginal distribution means that I'm going to use these numbers in the margin over the overall total, okay, which in this case is 131. Okay, so what I'm going to do is talk about the three types of pizzas. I have cheese. Okay. I have pepperoni. I'll abbreviate if you don't mind. And then I have loaded. And because it's marginal, okay, that means all of these will be some fractional representation of a value over 131. And if I were to ask for, again, marginal distribution, notice the bold word here, all in caps, because it does make a difference. The number of cheese over the total, let's see, cheese total, 42. So I'm going to put that on top. The next one is pepperoni is 63. That number goes on top here. And loaded is 26. Okay. People ask, do I have to reduce my fractions like I did in previous classes? And the answer is no. You can leave it that way. It may be helpful to write as a decimal though, because we're going to have to make a bar graph for this. Okay, now bar graph. I'm going to make this as clean as I can here. Ooh, that's a bad start. And so is that, but that's okay. I've got cheese. I've got pepperoni. Oh, I have no idea what I just did. I don't want to do that. Let's see if I can make this smaller. Yeah, I can. Okay. And where am I at? I lost my pointer. There I am. Let me do this one in purple if I can. Cheese, pepperoni, and this is loaded. Getting too close to the bottom. Learning curve. Okay, so let's think about this. 42 divided by 131. You'd have to do this in your calculator. And so I'll do this real quick. Oh, I can't do that. 42 divided by 131 gives you about 32%. Okay, so here's what I'm doing. I'm going to count by tens. Okay, and this will be 0.1, 0.2, 0.3, 31%. I'm sorry, I'm getting used to this pad here. All right, next one. 63 divided by 131 is around 48%. So let me take a look at where that would be. Pepperoni, 48%. That's a better bar. All right, so here's 0.4, 0.5. Okay, and loaded is 26 out of 131. So 26 divided by 131 is almost 20%. So that will go here. Okay. Now, what I want to do too, and this will sound pretty elementary that I'm requesting this, but it's an important AP feature. They would like you to label your graphs. Okay, on an AP test, the one you take in May, if you don't label it, you're going to lose about 1/3 of your points. Okay, so what I'm going to do here is I'm going to call this pizza type. Normally I would put it underneath my pizza types just because it'd be easier to see, but I ran out of room. And this here, I'm just gonna call this my proportion. I'm gonna call this P of X. And I don't mean to make that sloppy, but that would go somewhere just to the left here so that we know what we're talking about. Okay. And that is it. Pretty easy, okay? Next part, okay, is give the conditional distribution of pizza types for Thursdays. Okay, so all I care about is Thursdays, okay, because that's what they ask. Okay, and so that means that for each of these, cheese, okay, pepperoni, and loaded. By the way, let me fix this guy. I'm going to need some values out of not 131, but the more specific variable that I have, which is related to the days of the week. In this case, it is a Thursday, and this is out of 37. Okay. Now, what's going to go on top? Well, it's going to be all the numbers that you would see within that work. Okay, so it's these ones that you would see for a Thursday. In green. Okay, so I'm going to shove those in. I've got 12 here, I've got 17 there, and I have 8 here. Okay, it does not ask me to make a bar graph, so I'll just leave this set of answers as it is. Okay. All right, the last one says give the conditional pizza type space for a Sunday. All right, and so basically for a Sunday, you can see that I've got 94, and I'm going to write again cheese. I've got pepperoni, and I've got loaded. Okay, and I'm going to write the number 131 for each. Oh, not 131, 94. Let me fix that. Darn it. $94. I don't know how to erase. Sorry. 94. 94. Okay, and then again, I'm going to have to decide what goes on top. And this won't be too bad as I look at maybe some blue here. Those are the numbers that go on top. All right, so I've got 30, I've got 46, and I have 18. Again, do I have to reduce? You don't, you can just leave it like that, okay? So you are set, those are the conditional distributions. Conditionals always have totals that are on the side, okay? Whereas marginal will always have a total that's represented on the overall, okay? So keep that in mind. All right, last thing is this, is based on the data, can we conclude that the pizza types differ in sales based off the different days? Okay, meaning do Thursday's pizza representations have a different set of percentages than a Sunday's representation? Okay, and so it says use a double bar graph or a segmented bar graph to verify. Okay, so here's what's going on. If I'm making a double bar graph, I'm getting better at this. I am not. Okay. What that means is I have to look at 3 different categories: cheese, I have to look at pepperoni, and I have to look at loaded. Okay. And I'm pretty much going to need some percents for each of these. It's kind of a pain, but I'm going to have to take all of these that I have right here and give some percents. Okay, so here's what I'd like you to do for the sake of not wasting our film time. I'm just going to put this on pause. I'm going to have you do that. Okay, so pause. All right, did you pause? Did you pause? I paused. And the reason why is I wanted to find these decimals real quick. Okay, so Here's what you get for those respective 3 for Thursdays, and this is what you get for Sundays. And I'm going to put them on my graph here, okay, and make a double bar graph. So what I'll do is I'm going to let my first bar for Thursday be a gold bar. And let's see, let me put some tick marks up here. Let's count by maybe 10% still. You're like, that's hard to read. 0.20. It's conflict I have because it is some double gold, okay? And I know it's not pleasing to the eye with respect to making this graph. It's kind of hard to see, but you do feel an inner pride as you work through this problem, okay? All right, and again, these are percentages. Just P of X is fine. And on the bottom, I'm going to write here, these are pizza types. All right, now I'm going to identify gold with Thursday. Okay, so here's my little key. And it looks like for cheese, I have to go up to, look at this number here, 32%. So 32 for cheese. Ugh, that's a bad bar. Therefore, I will just fill it in. Make it look a little better, okay? All right, the next one is 46%. So for pepperoni, I'm gonna go up to 46%. Okay, and then the loaded is 23%, so not too many here. Okay, and then I'm gonna do the same thing for Thursday, okay? Now, when I do Thursday, I don't wanna use the same color. So I will pick something, sorry, Sunday, I wanna use a different color, Sunday. In Sun Double Maroon. And you can see that the first one is also 32%. If I did my math right. Okay, 49% for pepperoni. Okay, and the last one is loaded is 19%. Okay. And you can see that, yeah, between the couple of days that we have, there's really not too much difference. Okay, the bars were pretty representative of the types of sales that you had based off the type of pizza that you had for each of the 2 respective days. Okay. All right. Finally, a segmented bar graph. I'll do this in maroon just so you can see it. Here's what you're going to do. You're going to do 1 for Thursday, and I'm just going to make these both in maroon. I'm just going to call that TH, and 1 for Sunday. You're going to make 2 bars that are the same length. And I barely have enough room. And here's what you're going to do. You have to know that each of these must total 100%. Okay, and that's why they are both the same length, because you're dealing with percentages. Okay, so if you look at cheese, it's about 32%. And I'm just going to write that about a third of the way, because that's what 32% is. Cheese, 32%. Okay. The next one is 46%. That's about half. Yeah, I don't know, maybe about right there. 46%. And that is pepperoni. Okay, and the last one is loaded is 23%. I don't have to draw anything further. That's the last quarter of your picture. Okay, last quarter of your segments. Now let's put an L there for loaded because I'm out of room. You'll find that your Sunday one will look very similar. In fact, the 32 is identical. Okay, your pepperoni is a little larger, okay, because it is 49%. Okay, and the last one is the loaded, which is 19%. Okay, and you can see that the bar is just a little bit smaller than the 23. Okay, and that is a double segmented bar graph. You don't see these a whole lot, okay, but they do come up now and then. All right. All right, so big thing, be careful on conditional and marginal distribution. Marginals have totals over the overall total, okay? Whereas conditionals will have denominators that are represented more in the margin, okay? The ones that are off to the side here, okay? Either on the bottom, okay, or the ones that are listed vertically, okay, but not the overall total. Okay? All right, give those a shot. They're a little wordy and a little bit difficult at times when you're doing these charts, okay, but give your best shot. And if you have some questions, you let me know, okay? I'm happy to work those out with you if you have some struggles. All right, hope you're having a great day, and I will talk to you again soon. There's your assignments. Not as nice as the last one, but again, most of your answers are just fractions. Wow, just a black screen now. That's no fun. See you later.